Ladies and gentlemen, class recording has started. So, last week we began this unit dealing with our introduction to mechanics, and we said mechanics deals with the study of motion. And we said our study of motion centers around 4 questions that we would like to answer about that object. And if we can answer those 4 questions, we're doing a good job of describing the motion of that object. So, the first question we talked about was, where is the object? Right now it's position, or it could be displacement, depending on if we're moving around. Okay? The second question we talked about was, what is it doing? All right? And we said that could be speed, or that could be velocity, depending on how detailed we want to be. And then, over the past couple of days, when we were dealing with the graphs, we also included the when, right? When is it doing this? When is it in this position, right? And that was the third question. So the fourth question that's left is why? Nope, that's next chapter. How? Right? So the fourth question that we have to answer is, what will this object be doing in the future?
I didn't hear it either.
Yeah.
All right, so that's the fourth question if we're just going to describe the motion. In the next unit, we'll get into more explaining motion, and that's when we start answering the why question. Okay, so hang on a couple weeks. All right. So answering the question of what will be happening next, we have to introduce a new term, and that term is acceleration. All right? So, acceleration is another one of these terms that you need to understand the actual definition of it. Most of you are familiar with the term acceleration, but the concept of acceleration is doesn't quite match up with what you use that term as now. All right? So, make sure we pay attention moving forward so we get the proper interpretation or the concept of acceleration, at least as it relates to mechanics. So, we define acceleration as the rate at which velocity changes. If velocity tells us what the object is doing now, in order for it to change, that would be what is it going to do next, right? How much is it changing? And that will tell us what's going to happen next. Now, we said, and we talked about this last week, whenever we define something as a rate, what does that mean? Over time. Not always distance over time, it's something over time, right? So, what are we going to measure over time? Not just velocity, but the change in velocity. How much is the velocity of that object changing? That being the case, how do we represent that mathematically? Well, we know that rates are represented by what mathematical expression? Fraction, right? Okay, so how's it going to look?
Is it going to be like final velocity minus initial over...
Final velocity minus initial velocity over time, or we could summarize final velocity by minus initial velocity as what? Delta V over T. Because what does delta mean? Change, right? No. For acceleration, you're trying to find how much does the velocity change. Right? Notice I've said change like 15 times since we've been looking at this slide. It's the important part of acceleration. A changing velocity. Okay? And mathematically, we represent that as delta V over T. Okay? All right, let's do concepts. Like I said, Devin, go ahead. Oh, sorry, units, duh. Yeah. All right, sorry, I forgot about the unit part. Okay. So let's go here. Okay. We get out of here. We go here. We go here. Okay. We define acceleration like this. Delta V over T. And Devin, like you said, we could expand that out so it could look like this, right? Those two expressions are basically the same, just one's more detailed than the other one, okay? All right, if we subtract two velocities, they both have to have the same unit. And what unit do we know that velocity has? Meters per second. So we have meters per second here, right? Then what unit do we use time? Seconds, right? So this unit right here is actually the unit for acceleration. Meters per second per second. It's a complex fraction, right? It's got the fraction within a fraction, all right? This is descriptive. Meters per second per second. How much does the velocity change every second? Okay? Now, while this is descriptive to tell us what's going on with acceleration, it's not always convenient to write it this way. Okay? So, we simplify this expression, okay, and we turn it into meters over seconds squared. Okay? That is the equivalent fraction of meters per second over second. Okay? Now, hold on one second. Let me do one thing. Okay? Let me do one thing. Now, don't be misled by this. Okay? While that is the equivalent fraction for meters per second, if you know that something travels 10 meters and it takes 10 seconds to do it, if you plug 10 meters into the top of that fraction and 10 seconds squared on the bottom of that fraction, you will not get the acceleration. Okay? That's not what that unit tells you. This unit is a simplification of that unit. Calculating acceleration is not as easy as taking a distance and dividing it by a time squared. That's not what it tells you. Okay? So don't fall into that trap, because sometimes we do. Okay? Steven, question? Are you good? Okay. All right. Are we okay with this for now? Okay. Now, let's talk more about conceptually or qualitatively what is acceleration. All right. Taking into account the definition of acceleration, there are three physical things that can happen that fit this definition. We generally think of one as acceleration, but there are other ones that fit the definition. So generally speaking, when we talk about acceleration, what do we picture in our mind, or what physically is happening? Something is speeding up. And while that is a form of acceleration. So this guy diving off the cliff, as he falls, gravity causes him to go faster and faster and faster and faster. That does fit the bill for acceleration, because his velocity changes. Okay? But there are two other things that fit the definition. Oh, if you look at your outline, letter B underneath this Roman numeral number 4, three things that can be considered acceleration, or three motions that can be considered action. So the first one is speeding up. Okay? Yeah, we're jumping down a little bit. All right. What other motions could be considered acceleration based on the definition? Slowing down is also a form of acceleration. Because what has to happen to the velocity of something in order for it to slow down?
It has to go down.
It has to, well, more generally, it has to change, right? And that's our definition of acceleration. Okay? Even though we don't call this acceleration, it still fits the definition. Right? Then, there's a third thing that fits the definition. Anybody? Changing direction. What do we know about its velocity? Velocity is a what? It's displacement over time, but it is a vector quantity, meaning that it has to tell us magnitude and direction. If you're on this merry-go-round, right, at the beginning you speed up and at the end you slow down, but in the middle of the ride, you're going around in a circle. You're not going any faster or any slower, but you are accelerated because your velocity is continuously changing because you keep going in a different direction. So, speeding up, slowing down, changing direction. All three of them fit the definition of velocity. Of acceleration. Okay? Good there? So how do we distinguish between the three of them? Well, it comes back to this. Okay? So we said that this expression right here describes what's happening in velocity, acceleration. It's changing. Okay? When something speeds up, what's true about its final velocity versus its initial velocity? It's bigger. So if we plug a bigger number in here and a smaller number in here, mathematically, what are we going to end up with on the top of that fraction? A positive number. So speeding up, we consider what? Is positive acceleration. Alright? But when something slows down, what's true about its final velocity versus its initial velocity? It's smaller, right? If something goes slower, then it's smaller, right? So if we plug a smaller final velocity and a bigger initial velocity, what happens on the top of that fraction? It's a negative. So slowing down is negative acceleration. For the record, changing direction is something called centripetal acceleration, but we're not going to deal with that in this class, all right? Know that it's acceleration, but you don't necessarily have to know positive or negative. Tomorrow, we'll get into the packet that I handed out to you, and we'll start putting some numbers on this idea.